Now, away from valency and mole ratio, we shall now be talking about balancing of equations. When we look at balancing of equations, we make reference to that branch of chemistry that shows or studies why and how reactants and products must have a steady, balanced relationship. That is to say, a given reactant A and B coming into reaction to give us a product C and D must have a balanced state. Otherwise, such reactions may not really take place. To balance an equation, numbers called coefficients are placed in front of the reactants and products to ensure that the number of atoms are equal. For example, the reaction between hydrogen and chlorine to give us hydrogen chloride. 2 atoms of hydrogen, or we can say 1 mole of hydrogen, is coming into reaction with 2 atoms of chlorine, or we can say 1 mole of chlorine, and it gives us 2 moles of hydrogen chloride gas. So looking at the equation we have on the screen, we can see that hydrogen at the left hand side is 2, chlorine at the left hand side is 2, and at the right hand side, the 2 in front of HCl is for both atoms of those elements. The 2 in front of HCl is for both hydrogen and chlorine. So it means that hydrogen is 2 at the right hand side and chlorine is also 2 at the right hand side, an indication that the equation is balanced right and left. Hydrogen is 2 left, hydrogen is 2 right. Chlorine is 2 at the left and it is 2 at the right. So it tells us that the equation is absolutely balanced. Let us therefore take a look at the rules for which we ought to balance any given equation. Taking out these rules or steps, we begin with the first step to balance equations. The first step is first we itemize and count the number of atoms at the left hand side and at the right hand side. The left hand side is reactant side and the right hand side is the product side. So first we itemize and then count the number of atoms at the left and at the right. The next step is to identify the unbalanced element or elements as the case may be. After itemizing, we then identify which of the species is balanced and which is not balanced. Step 3. Having identified the balanced and unbalanced species or atoms of elements, we now have to fix in coefficients to balance the unbalanced elements. But in trying to balance the species that are not balanced, we ought to be very careful not to disrupt the already balanced ones. Otherwise, we also have to balance it if they become unbalanced or if they become affected in trying to balance the unbalanced species. That is the step 3. And lastly, it is worthy to note that in trying to balance equations, coefficients must not be placed as subscripts or even superscripts. That is to say, we place the coefficient numbers in front of the elements. We don't place them or write them as subscripts. So, those numbers we use must be written as whole numbers in front of the elements, not as subscripts neither as superscripts. So let us take a look at examples of how to balance equations. So we are going to take a look at these equations and take a step-by-step approach to balancing these equations, one after the other. Looking at the first equation, equation A, we have, now we're going to see how to balance that. Let us see. Just carefully take this up and then we proceed. So equation A, we have iron reacting with chlorine, and it gives us iron 3 chloride. Iron 3 chloride. So how do we balance this equation? Let us take a look at our rules once again. The first rule says we itemize. Iron is in solid state, this is gas, and this is solid. So the first rule says we itemize the species. All the participants in the equation ought to be itemized, and then we take our counting. So from the left hand side, let us take a look at how to balance this equation. From the left hand side, we have iron, we have chlorine at the left hand side, and at the right hand side also we have iron and chlorine. So at the left hand side, how many ions do we have? We have 1 ion and we have 2 chlorines. At the right hand side, we have 1 ion and 3 chlorines. So the next rule says we identify the unbalanced elements. From what we have, it is clear that iron is balanced because it is 1 at the left and 1 at the right. But chlorine is having trouble because it is 2 at the left and 3 at the right. So we have identified the unbalanced elements. The next step says we have to fix in coefficients to balance the unbalanced species, the unbalanced elements, so to say. But in trying to balance that which is not balanced, we ought to take care not to disrupt the already balanced participant. So let us proceed to looking at how to balance that. Never mind, even if we happens to disrupt the already balanced species, it means we'll have to still place in numbers to make sure everyone is balanced. So let us take a step to looking at how to balance that equation. If I'm to balance this equation, we can carefully place 3 in front of chlorine, and chlorine will now become 3 times 2, which is 6. That is to say, chlorine is no longer going to be just 2, but it is going to be 3 times 2. So chlorine is now 6. Chlorine is now 6. No more 2 or 3. Chlorine is now 6. And at the right hand side, we have to look for a way to balance the chlorine. Chlorine is still 3. So in trying to balance chlorine, what do? We can place 2 in front of iron 3 chloride. So to place our 2 in front of iron 3 chloride, it makes chlorine to become balanced. That is, chlorine will become 2 times 3. And 2 times 3, of course, gives us 6 also. So we have this. We have this now. Chlorine will become 6. 2 times 3 is 6. So chlorine is balanced with the other chlorine at the left. But iron has been affected. The 2 we placed in front of iron 3 chloride has made chlorine to become balanced, but it has disrupted iron. So iron is no longer 1. It was 1 before, but now it is no longer 1. Instead, iron is now 2. So how do we make iron to be balanced with the 1 at the left-hand side? To do that, we simply impute 2 in front of iron. And with this, the equation is balanced. For some students, they may think we have to place 2 in front of iron this way. That is to say, please never attempt to place 2 as subscript. I want to feel some persons feeling like we should place 2 just here and never here, never in front of iron. Some persons may place 2 in front of iron that way as a subscript. So we have violated one of our rules that says that numbers shouldn't be used as subscripts or superscripts. So take note of that. We shouldn't balance equations with subscripts. So all equations must always be balanced with coefficients. That is whole numbers, coefficients. So with this, we have seen that all species are now balanced. We have seen that all species are balanced. This ought to be 2 and not 3. So we have 2 in front of iron. So with this, we have all species to be balanced. Iron is balanced, left and right. Chlorine is balanced, left and right. So this is how equations are balanced. Let us take a look at the second equation. Equation B. It is between zinc and hydrogen chloride. Zinc and hydrogen chloride. Aqueous to give us zinc chloride, aqueous, and hydrogen gas. So, how do we balance that equation? Just as we have seen in the first example, we have the left-hand side. Zinc is 1, hydrogen is 1, chlorine is 1. At the right-hand side, zinc is 1, hydrogen is 2, chlorine is 2. So if that is the case, how do we make hydrogen and chlorine balanced? It is clearly seen now that zinc is balanced left and right, but hydrogen isn't and chlorine isn't. So how do we make the hydrogens and chlorines at the right hand side to become balanced with those at the left hand side? To do that, we simply have to put 2 in front of HCl. I want to feel some students will likely say we place 2 this way and place 2 this way. Please, if you're thinking so, you have violated one of the rules, the 4th rule, which says that numbers shouldn't be balanced. We shouldn't balance any equation with subscripts. So it is very wrong to do that. You are actually violating one of the rules if you happen to do that. So to balance that equation, we simply have to bring in 2 in front of HCl. That 2 is for both hydrogen and chlorine. It does not belong to hydrogen alone, neither does it belong to chlorine alone. So this is how the equation ought to be balanced. So with this, we can rightly say that our hydrogen is now 2, no longer 1. Our chlorine is also 2, no longer 1. And for now, zinc is balanced right and left. Hydrogen is balanced right and left. Chlorine is balanced right and left. So that is how to balance equations.